Cool. All right. Well, let's start with questions. Wow, why am I green? That's a good question. Oh, that's not bad. Huh. Maybe I'm still under the weather from the shot because I look green to me. Let's try that again. So that works. Oh, it's just gonna be green day. Okay. Could be a shared delusion. That's always possible. That's a little better. It's probably the Hendrix effect, you know. All right, we'll live with that. So how is stuff? Yay. Got some dots showing up. Excellent. If you can make one dot, you can like conquer the world, right? It's all about the hello worlds. And a scalable window, cool. Connecting the dots is the next challenge. And I would say start with trying to identify like which box you're in, and then do that business of trying to find which edge you're closest to, which I still have my slide of, right? So just find those distances to each edge. Find the smallest, that should tell you which side you're closest to. And then once you know, I'm at the bottom of box 3, 4, then you go through your coordinate arithmetic to figure out coordinates for box 3, 4, bottom edge, and then call draw line. Let's see, how would you keep track of which edges are clicked? Multi-dimensional array? Yes, so I'm gonna say let's do a class box and have some booleans. Top, bottom, left, right. Set those all to be false in your constructor. And then when you click an edge, well, so and make your class board. And have game board, which is an array of boxes. So box. And so if you want to check the box, for the bottom edge, check the line for the bottom edge in box 3, 4, it's just going to be game board, bracket 3, bracket 4, dot bottom equals true. And then in your paint method, just iterate. So for rows 0 to 7, column is 0 to 7, box B equals game board, row, column. And so now just check the sides of this. If B dot top is true, then, but maybe do some calculations first, figure out the XY coordinates for at least the upper left corner based on the row and column. And then if, B dot top, then draw line XY, X plus cell width Y. If B dot bottom, then draw line x comma y plus cell height comma x plus cell width comma y plus cell height, and so on. And you can put print statements in your print method. I wouldn't leave them there. You know, once your code is production ready, but you can put print statements in there to kind of see, you know, which boxes it's finding lines in, and so on and so forth. Could one box's left side be set to a pointer to a different box's right side so that they are always the same side? There might be a way to do that. So the only way I can think to do that is if you made these things instead of primitives like a Boolean, made them, you know, objects of type Boolean with an uppercase B, and then you could just set, you know, one box's left and the corresponding neighboring box's right, make those the same object. I think you could do that, but that's going to simplify, you know, checking a box, so that if you're sitting in here and you click the bottom and you set this to true, that would automatically set the top part of the following box below it to be true. But it's going to be tricky to get that right. So you may need more debugging to get it set up, but then using it is going to be a lot easier. So that would be pretty slick. The other option is, you know, every time that you find, if I'm in box, you know, 3, 4, and I decide that I'm going to set the bottom to be true, add 1 to the row. So now I'll go to box 4, 4 and set the top. If I mark the top of this box, then subtract 1 from the row and set that box's bottom. If I set the left, subtract 1 from the column and set that box's right, and so on. And just be careful if, for example, you set the top line in the top row, don't go to, you know, row -1, because you'll segfault. So put some boundary checks in there. So that's you know, a chunk of code, right? That's a good thing to throw off in its own method, right? So you don't have, you know, 16 lines of squishy looking code in the middle of, you know, your mouse handler. Throw that in a separate method, you know. Mark line, row, comma, column, comma, which line you want to mark, and it can do all of that stuff in the method. And then once that's working, you can just sort of, like, you know, seal it in bricks and not have to look at it and know it's doing its thing. There is a built-in drawLine method, so it's called drawLine. It's crazy, these Java developers. So look at the graphics class. And under methods, drawLine takes a pair of XY coordinates. So starting point x1, y1, ending point x2, y2. Yeah, very sneaky. If you don't have a drawLine method, how would you draw a line? What would you have to do? You could do a very thin oval. What if you didn't have an oval method or a rectangle method? Or for that matter, how does drawLine work? Change the color of the pixels in between. That's really what's going on, right? If you want to draw a line from here to here, something somewhere is saying, hey, this pixel right here, this should be blue, and this pixel here should be blue, and this pixel should be blue. And it basically turns all of those pixels blue, and our brains look at that and say, oh, that's a line. It's really a bunch of pixels, but we see it as a line. And if you're drawing a horizontal line, it's not too bad to do that. If this was, you know, 10, 50, and this was, you know, 90, 50, Well, I could make a for loop. I could say for x goes from 10 to 90, draw a pixel at x comma 50. And that would light it up. And there's do we have a draw point? We might not even have a draw point. But somewhere there's a way to turn on an individual point. And so for a horizontal line, we could definitely do that. And for a vertical line, right, we could just change the y coordinate from here to here and say turn on all those pixels. But here's a general question. This is maybe an interview question. How would I draw this line? How would you figure out what pixels you needed to light up to make that line appear? Find the slope of the line. Excellent idea. Find the slope of the line, and remember slope tells us, you know, rise versus run, how far over to go, how far up to go. And insert pixels accordingly. So if your line is mostly like this, you're going to want to move over and go up however much, right? But you want to move over 1 pixel at a time. If your line is more vertical, then you need to move up 1 pixel and figure out where to draw, and so on and so forth. Pythagorean theorem is in there. That would tell us, you know, in some sense how many pixels. And so there's algorithms for doing this. There's a classic algorithm called the Bressenham scan conversion algorithm that basically lets you figure out which pixels correspond to a line between 2 points. And it gets extra interesting. This is just sidebar note here. Let's say this is the point 1020, and this is the point 121. So if you try to draw a line between 1020 and 121, right, from here to here, you go up 1 step in y. Y is 20 to 21. Your line's pretty much going to look something like this. Assuming that's the distance of 1 pixel, it's got this little jump in there. And that can be a problem. So I've got my resolution up pretty high, but if I turn my resolution down, you can see it happening right now actually. If you look at the top edge of this, you can see a little jaggediness right there and right there and there and there. And you can definitely see it there. There's like a sawtooth kicking in. Right, well that's a consequence of the fact that, you know, you've only got so many pixels on your screen, and as you move from one level of, say, y to the next, there's going to be a little jump there. And if your line is perfectly horizontal, you don't get that effect. But if it's slightly off, you'll start to see that rasterizing going on. Yeah, like Doom. So that's aliasing, right? That's a phenomenon that's kind of inevitable because our screens are really, you know, a bunch of horizontal lines that we get to blank when we want. But the screen, if you put it under a microscope, it's a whole bunch of horizontal lines. And all we get to do is say, you know, turn it off here, turn it back on here, turn it off here, turn it back on there. Rip and tear, yeah. So what you do, how do you anti-alias? Well, you know, if you're drawing a line that's supposed to go from here and jump up here, every time that you get a little jump like this, you light up a few extra pixels. And you don't make them quite as dark as the line you're drawing, but you throw in a few extra pixels basically to smooth it out so that, remember, our brains are what's turning these individual pixels into a line. You can trick your brain into thinking that that's a smooth line from one point to another. and not getting hung up on these little jagged edges. So there's all this stuff going on, right? And for the most part, at this level, we don't even have to think about it. It's all handled for us. But if you're down at the level of, making a device driver or making a graphics library or something like that, then you need to start to think about these kinds of issues. So like I say, that's just bonus material. All right, cool. So other questions? There will not be GUIs on the test tomorrow. Yeah, let's talk about the midterm. Because people might be wondering about that. So yeah, midterm, I'm planning to do everything up to when we started talking about GUIs and Java and Swing and Eclipse, but none of that stuff will be on the test. So everything up to there, so basically the first 3 programming assignments, all of that material. So mostly just Java coding and knowing about Java. So let's see. So yeah, Java, classes and objects. Object-oriented programming. So this idea of taking data and code and putting them together into these things called objects. So object-oriented programming, and related to that, information hiding, which goes along with abstract data types. So a stack is a data structure where you can push and you can pop. The implementation of the stack might involve an array or a linked list, or a combination of those and pointers and so on. And so those implementation details, those get hidden from the user. And your class for implementing a stack would present to the user an abstract view of a stack. Hey, you can call this to initialize, this will push, this will pop, this will tell you if it's empty, and so on. And then the details of how we do that, those are hidden. And so this gets into the idea of like public and private. So being able to hide things from the user. Yeah, I'll ask you about triangles. Like, how do you spell triangle? So publics and private, this also gets into the idea of accessors and mutators. So if we have something that's hidden from view, but you still want the user to be able to get to it or modify it in a controlled way, you can write an accessor and a mutator, but do it on your terms. How many sides are on a triangle? What's the Pythagorean theorem? Find the mass of the sun. How do you spell triangle? But if the triangle was a sun, how much would it weigh? There you go. Yeah, I won't put physics on there. That would be a massless, frictionless box sliding down a triangle, right? While spinning on a carousel with a child playing with a slinky. Yeah, I still can't do those questions. So yeah, basic ideas of object-oriented design. Let's see, bundling of methods and yeah. So I won't ask you this term, but let me just put it on here: encapsulation. Which is really binding data and code together. And those are sort of like the two things that people say are kind of like, the keys to object-oriented design is this notion of encapsulation and information hiding. So they're two concepts. I believe you can get through life without being able to calculate the speed of a sliding cylinder. Um, but can you get through physics without knowing it? That's the deeper question. Um, so yeah, let me talk about logistics, and then we'll go back to topics. Logistics. So the midterm is at 10 o'clock tomorrow. Okay. Um, so it's 10 o'clock to 10:50 Friday. It's not posted in the morning, and you can take it anytime you want. You got to take it 10 o'clock to 10:50, and it will show up as an assignment. Okay, it's not going to be a Canvas quiz. It's just going to be an assignment. So it will open up at 10 o'clock, and it will be a PDF file, and you can look at that, and that will list a number of questions for you to do. Write up your solutions to the questions, save them as a PDF, and upload that by the deadline. Okay, so it's not like a copy and paste into Canvas like I've done in the past. It's just, write your code, save it as a PDF, upload that. If you can do it as one PDF, that's best for me, but if it comes in separate pieces, I'll work with that. All right, let's see. So it's open book, open note. You can use your old assignments. You can use anything you've got written down, but nothing online. So no online resources. Obviously, no Stack Overflow or Chegg or Skype or anything like that. Let's see. I think I set it up so that you can use. Well, let me take a peek what I got here. It's not finished, but I got the beginning of it. So you can use a basic editor, but don't do anything that autocompletes or checks syntax or things like that. Don't use Eclipse, right? You can use VI, you can use Nano, you can use gedit, Notepad, Notepad++, things like that. I'm not going to force people to turn off syntax highlighting, so if you have syntax highlighting, that's okay. I don't think I put any multiple choice on. Yeah, you can use your GitLab repos, and if you hop online to look at your GitLab repo, that's okay. That's like an extended version of your notes. But when I say no online resources, I mean no Googling, things like that. And yeah, just write everything up, save it as a PDF, upload it by the deadline. The assignment will not close out automatically at 10:50. Okay, so we've done this before. It will stay open indefinitely. So if for some reason you don't get it uploaded by exactly 10:50, you can turn it in a few seconds late. Okay, but I'm going to dock 10 points per minute. So it's not an opportunity to get extra time. It's just saying if you're 10 seconds late, I don't want you to get a 0. Okay, so I'm not going to have it lock you out at the end of the time. If you have an extended time allowance, just take the extended time, and there's no. It'll say it's late when you turn it in, but I'll grade it based on your extended allowance. I'll be in Zoom during the exam. I recommend you hop onto Zoom. If there's a correction or something like that, I'll mention it in the Zoom session. If I ask you a question that's impossible to do, right, I'll tell you about it in Zoom. So if you're not in Zoom, then you can't hear that. I'll try to give you a mention a few minutes before, but I don't want to, be the voice of doom. If you're working against time pressure, I don't want to keep coming in with like, you got 3 minutes left, you got 2 minutes left. Yeah, set a timer on your phone. And maybe I'll throw a countdown clock up. I don't know. Clocks kind of like worry people. But I'll try to remind you when you got a couple of minutes left. Or set your watch to beep once a minute like White Rose, right? Alright, what else can I tell you about the exam itself? Upload a PDF, right? I prefer that people type this rather than write it by hand. And, it's generally going to be faster to type. Um, save as a PDF. If you're not sure how to save as a PDF and so on and so forth, figure that out before the exam. So don't be stuck, at 1050 trying to save as a PDF and it won't let you export and stuff like that. So just try it out ahead of time. Anything else on logistics? I think that's pretty much it. And obviously, as usual, if there's questions, just go ahead and ask in Zoom. Yeah, don't use Word, even though it is the best IDE ever, right? I'm not going to be super picky about formatting or comments, but if your code doesn't make any sense and it's all left justified and there's no comments, it may be harder for me to figure out what you were trying to do. So to the degree that you think it's important to clarify, try to make it pretty and well commented, but don't spend time doing that unless it's in your interest. Yeah, I do have students sometimes who end up getting saved by their comments. Word has bested me too many times though. I'm sure if you bully it enough you can get it to behave, but it actually enjoys playing these games and I don't. So I usually just surrender. It's like, okay, yeah, I'll use this font. Is left justified actually a thing? Some people do write code totally left justified, they just don't indent. And it's not, required to indent for the program to work, although in Python it is. In Python you indent instead of using brackets. But yeah, that does happen. Use ktransfer to Word to make a PDF. And most systems you can print and say save as a PDF, so you can actually go straight from Kate to a PDF like that. But if you can do it through Word, that's fine too. All right, I think that's it as far as kind of the logistics of the midterm. And if you've had classes with me before, it's exactly the same drill that we've always done. Nothing special or different going on. So back to PDF document. It'll be set up to only accept a PDF. So back on topics. So you should know that Java is compiled and interpreted, right? It's compiled into bytecode, and then that bytecode is interpreted by the Java Virtual Machine, the JVM. And so you get portability, you get a little bit of a speed hit, but it makes it movable from one system to another. Let's see, object-oriented, basic syntax. And if you know C, you pretty much know Java syntax for the things that aren't class related. It's, if statements and loops and variable assignments and variable types and things like that. So most of that's familiar from C, but also the Java specific stuff. So, defining a class. Public static. Void main, all of that stuff. Should know about signatures. So the idea that you can have more than one method with the same name, but they're still different methods because the name and the types of arguments together form the identity of the method, so the signature of it. You should know about constructors. right? So making a method named a constructor, which looks just like a method except it doesn't have a return type, right? So constructor is like a method, but it basically is called when you make an object, and that gets called by using the new keyword. So box B equals new box, that kind of thing. Getting lots of good exam ideas in here. Yeah, don't turn in a PDF in machine code. I'm not asking about Java docs, so you're good with that. Yeah, let's write Java in machine language. I've never written in bytecode. That seems like a good thing to know how to do. Alright, what else should we know about? Definitely know about try-catch blocks. And know the syntax for that so that you can write try-catch blocks and also understand the concept of it. And the two things to know about it conceptually are, one, that argument that we put in the catch block that says, usually exception E. That class exception can be, any class that might match the kind of exception that's been thrown. So we can catch specific exceptions. So try, catch, and finally. So there's 3 parts to that. But the most important thing to remember on these is to keep them small, right? If you think that line, 87 of your method might throw an exception, don't put the whole thing in a try-catch block, right? Put a try statement at line 86, and then put in your statement that might fail. Would it be specific exceptions or just the general know-how for try-catch? I'm not going to ask you about specific exceptions. But if you need to know about them at some point, right, the Oracle documentation is there. Oh, you can use the Oracle documentation, right? So all of these pages that we refer to, those are totally fair game. And finally is after a try catch, whether the statement succeeded or failed and went into the catch block. Either way, it will go ahead and execute the finally block when it's done. So yeah, it executes at the end regardless. You should know about static versus non-static. And I've been imploring you not to use the word static except for public static void main. But we did talk a little bit about what this means, this idea of a class variable versus an instance variable, so just be aware of that. I'm not going to ask you a lot about that, if anything. Let's see, arrays. So you declare an array with, either something like integer d equals new int 25. So that makes an array of 25 integers, and you're ready to use that right away. But if you make an array of objects, so if you say triangle t equals new triangle, right, t bracket something now has meaning, right? The compiler won't complain, but it hasn't been constructed yet. It's equal to null. So before I can actually use a triangle here, I would need to say this equals a new triangle and construct one. So with arrays of objects, we get this sort of double initialization we have to do, and it's something that we saw when we were dealing with dynamic memory, when we had a structure and we made an array of pointers to that structure. We had to allocate space for the array itself, and then we still had to allocate space for each of those structures. So it's the same idea here. So arrays of primitives, int, float, double, char, right? Those work just like in C. And arrays of objects. That's like pointers to structure, so that's where we have to do this double allocation. I can show it for like 10 more seconds if you want. So that declares T to be an array of 25 triangles. And this, for example, is constructing a triangle for T bracket 0. And then I could say, you know, T dot perimeter, or T bracket 0 dot perim. Side question for PA4, since we have to make an array of boxes, would it be bad practice to use a for loop in the constructor to allocate memory for each box? No, that's a good way to do that, actually. So you need to create 64 boxes, so yeah, that's exactly what I would do. Make a for loop, row 0 to 7, column 0 to 7, and set, you know, not in the paint method, but set, you know, game board bracket R bracket C equal new box. And then that would construct the box, and your constructor would do things like set these booleans to false, and set your flag saying if someone owns it to be clear, and so on and so forth. Yeah, you can do all kinds of things in constructors. Just be aware that, you know, whatever you do in there is going to happen every time somebody constructs this object. So for a box or a board, that's perfectly appropriate. But if you're going to, you know, print out a fortune every time someone constructs a triangle, that may not be what you wanted to do. Or the constructor that does nothing in particular, which seemed to get a lot of mention. All right, so arrays. Yeah, you should know about class extensions. Nah, I'm not going to put class extensions on there, because that's kind of PA4 stuff. So don't worry about class extensions. And the super keyword and stuff like that. Yeah, I saw your comments on that. That was awesome. Let's see. So you should know about things like, you know, linked list and hash map. So these classes that we've been using for some of our assignments, make sure you're familiar with those. Make sure you know about string. Right, strings are good. And you don't need to memorize this, right? Have the documentation available for these, but hash maps and linked lists, the interesting thing about those is they're generic. So for a linked list, you have to say what kind of thing you want to store in your list. For a hash map, you have to say what kind of thing is the key and the value. So you have a pair of classes you specify when you construct and when you declare. And, you know, linked list, we basically added some things into there. We looked for things and so on. Hash maps, you can store things and so on. Strings, so what do you want to know about strings? I don't know. I mean, the basic methods we've been using. So, you know, dot length, dot equals, character at, to uppercase, and so on and so forth. Right? You should ideally have, you know, this documentation handy somewhere so that when you're, you know, coding, you don't have to go on a wild goose chase looking for, you know, what was that thing that I used to compare two strings? Oh yeah, compare to, right? So have this documentation handy somewhere in general, but then you can use it on the exam. You should know about the toString method. And what's special about toString, which is when you have an object and you try to treat it as a string, the toString method is called to help you do that. else have I got on here? Don't forget, all the stuff that we've done from 222, including recursion and linked lists and trees. Because I could ask you to do something related to those. What else? Oh, so scanners and print writers. So know how to construct this, know how to use a print writer to do output to a file. And the whole idea of, has next and next, or has next line and next line, or has next int and next int, and so on. Yeah, I might ask you to play the stick game. I'll tell you how many sticks I took and ask you how many you should take. That could be like the 50-point question. There's 5 sticks left. How many do you take? I think that's basically it. I mean, I'm probably missing some obvious stuff that we do every day. Like, okay, so like how do you compile a Java program, right? What's the difference between .java and .class, and so on and so forth. But just because it's not on here doesn't mean I can't ask you those things. Java C, all right, 100 on the exam. There you go. So yeah, Java C to compile, Java to execute. Your file name should be called, something.java. Whatever your class is called, it should be in a file with the same name, .java. Your class name should always be uppercase. When you compile it, you end up with the same file name, .class. That's the actual object file. Class and file name have to match, yep. Yeah, show up just in case I think of a different question. Yeah, or I could put a game of dots and say, which line would you draw next? Your box game does not have to be smart, by the way. But it would be cool if you had an option to play against the computer. But that's above and beyond. Yeah. I don't know. I've never thought about it. That would be fun to throw a genetic algorithm at, though. See if it can become a box game master. Oh, that's nice. Yeah. I missed playing chess. I'd like to. I never got very good at it as a kid, but I'd like to get back to playing it. Cool. Yeah, I think it would be fun too. I think that's pretty much a good topic list. Oh, really? Cool. I stumbled into a Netflix series called Queen's Gambit, which actually turned out to be an okay series. There was 8 episodes, I think. Except the first 2 or 3 episodes were horrifying because it was all this really dark tragedy and just very unpleasant stuff. But once you got past that, I really enjoyed it. I just wasn't in the mood for death and dying and destruction. But yeah, so that was cool. Ooh, Ferengi chess. All right. Any other questions related to exam coverage, things like that? Can I give you the answers? I could, but I don't have the thing fully written yet anyway. But, you know, this is kind of where my brain is. I thought about a take home, um, but I think we can do a reasonable job with an in class. So, yeah, exactly, like the universe and everything else. Um, all right, so we'll do the midterm tomorrow, and then next week, we're up to week 7 at that point. So we're going to start talking about threads, and you're going to keep going on your PA4, but but we'll play around with, well, we'll do threads or networking. I don't know which, because you're going to need networking for PA5. You're going to need threads too. But maybe we'll start in with networking on Monday. Yeah, unless you can predict what I'm gonna write. So we'll do one of those starting Monday. So our goals for the remaining 4 weeks will be to talk about threading, so running multiple processes simultaneously from your Java code, which will be a whole lot easier in Java than it was in C. We talked a little about forks and exec and things like that. So we'll do that in Java, and this will also get us into looking at things like deadlock and live lock and how to share resources um, among multiple threads. We'll talk about networking, sockets, doing socketed communication, and we're gonna be able to do that pretty much fine with just scanners and print writers still, which is pretty marvelous. Because again, in C we've got to get down to lots of lower level stuff. So so we'll do networking. We'll play around with the URL class. We'll make a web browser and some things like that, and sort of see how we get more into the cloud. I still have some odds and ends I want to loop back to. I want to talk about writing generics. And doing more with class extensions, maybe talk about interfaces and the abstract keyword and so on. For PA4, do we have to comment Eclipse code? You should probably comment, yeah. I would suggest that. Yeah, that would be interesting. Um, so yeah, number of things coming down the road, um, and most of those will get into all kinds of other topics. Like we'll spend a while talking about client server models in general, and your PA5 box game will probably use a client server model, and that's a topic that will transcend this course. Um, you can use Git inside Eclipse. It's up to you whether you want to do that or not. If you get things set up just right, it usually works well. But if you get them off just a little bit, it can be really kind of a headache. Um, so it's up to you. If you can get it to work, it's a whole lot easier because it's just right there inside the IDE. But you also have the option of just doing it from the command line. Just go down to your source folder and push from there. Um, and yeah, there's an egit plugin in chat. That's good. All right. That's about all I got. So I'll have office hours tomorrow morning, and I will see you for the exam. I recommend hopping into Zoom, and it will just open up at 10 o'clock. So I'll be on a few minutes before, and I'll let you know when it's 10. All right, cool. Have a good one. I will see you tomorrow.